In this video, we are going to learn how to solve systems of equations by substitution. Now, this is part 2 of this set of notes. In part 1, we learned about substitution. In part 2, we're going to learn about different, basically what happens when we have no solution or infinitely many solutions or all real numbers. Let's begin. So types of solutions, kind of like graphing, we can have one solution, no solution, or infinitely many solutions. A system of linear equations might have one solution, no solutions, or infinitely many. You can also have multiple solutions, which we won't learn about right now. So, for example, your friend is solving an equation, and her last line of work says 2 equals 2. What does this mean? What happens when you have a true statement at the end with no variable? That means infinitely many solutions. Or also known as all real numbers. All real numbers would work as a solution. And let's say, as your friend is solving a different equation, and the last line of work says 2 equals 1. What does this mean? Well, 2 does not equal 1. What this means is this right here. That's big 0 with a giant slash is no solution. So, use substitution to solve the following systems of equations. Remember? I'm going to mark 2 kinds. Blue and red. That way it's easier for us to kind of know which equation I'm talking about. Do we have any more? No, it's just those 4. So the blue one and the red one. Oops, don't like that. Let's try that again. There we go. The blue equation and the red equation. I think it's going to be easiest because this one already has y solved. We are going to replace this y with that right there. And we know y equals x plus 4. So let's write our equation. Negative 4x plus 4y. And instead of writing y, we're going to write this, x plus 4 equals 3. Because, you got to go back to this. So let's do some simplifying and distribution and all that stuff. 4 times x, positive 4, times x is positive 4x. 4 times 4 is positive 16, so negative 4x plus 4x plus 16 equals 3x. Not 3x, just 3. So let's combine like terms. Negative 4x, positive 4x is 0x. 0 times x is 0. That basically cancels out. We're left with 16 equals 3. Is that a true statement? It is not. It is no solution. What would a graph of this system look like? It basically looks like parallel lines. 2 parallel lines. Remember, parallel lines that don't cross. They don't cross, which means they do not have a solution in common, which is what we're looking for, is what points do they have in common that intersect. All right, let's take a look at number 2. We're going to do this one by substitution. Y equals 3x minus 2, so we're going to replace this with 3x minus 2. So, negative 6x plus 2y, replacing y with 3x minus 2, equals negative 4. Okay, let's start off by doing some distribution. Positive 2 times 3x is positive 6x. Positive 2 times negative 2 is negative 4. So negative 6x plus 6x minus 4. You already see what's happening here. Combine your like terms. They cancel each other out. We have negative 4 equals negative 4. All real numbers are infinitely many solutions. Infinite solutions. What would the graph of this look like? Same line. Same line. Basically, 2 lines which are the same line, graphed on top of each other. Let's try number 3. Y equals 1/4 x minus 1. It's already solved for us, so we're going to replace this y with that, with this. So, again, writing the blue equation, negative x plus 4y, well, not 4y, but 4, 1/4 x minus 1, equals negative 4. Let's simplify the left side. Positive 4 times 1/4 is 1x. Positive 4 times negative 1 is negative 4. And then let's bring everything else down. Negative x plus 1x equals negative 4. Negative x, positive 1x, they cancel each other out. You're left with negative 4 equals negative 4. That is infinitely many solutions. Let's just write infinite solutions. What would it look like? It would look like a graph of this would look like two lines, which are the same line. Last one, we've got y equals 2x minus 1, and then we're going to replace this y with this y right here. So let's write the blue equation. Negative 2x plus y. Y is just 2x minus equals 2. 2x minus 1, there's nothing to multiply it with, not even a negative, so we're just going to leave it as 2x minus 1. Now, if this was a minus 2x minus 1, you would have to just apply that negative sign to it, but it's just a positive, so we don't really need that. So anyways, combine your like terms, negative 2x, positive 2x, they cancel each other out. You're left with negative 1 equals 2. That is not true. This is no solution. What would it look like? Two parallel lines. Because they never cross. That's why they have no solution in common. All right, let's take a look at the next page. Solve each system of equations below for practice. Roll a pair of dice, find the sum of the two numbers showing, and solve that problem. So they want us basically to, you don't have to do all the problems, do as many as you can. We're going to go ahead and do all of them, I suppose, because it didn't really take that long. So let me red, 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 and red. Ooh, it's going to be a lot of them because we've got like 11 problems to do. But let's power through them quickly, all right? Okay, so this is for number 2. We know that y, we replace y with y. So we have the first one, the red one, 1/2 x plus 4 equals negative x, this is the blue part, minus 2. And just get all the x's on the same side, plus x to both sides, plus 1x to this side. That is 1.5x. Let's get rid of everything else on this side. Minus 4, that equals minus 6. Okay, now divide by 1.5, divide by 1.5. You're left with x equals 6 divided by 1. I believe that's negative 4. So I plug that into one of the equations. Let's go ahead and plug it into the bottom equation, the blue one. This one right here. So y equals negative 4 minus 2. So y equals 4 minus 2, y equals 2. So my solution to that is negative 4 and 2. We want to check. Let's do a mental check. Let's see. 2 equals, let's see, 1/2. Yeah. This one, negative 4 times 1/2 is negative 2 plus 2. That's 2. Does 2 equal 2? Yes, it does. And then we already checked the blue one. Let's try number 3. You have 6x plus 2y. We're going to replace this y with this one right here. So we're going to have 2y. Sorry. No, we're not. We're going to do 6x. Whoops. Pen looks like it's dead or something. What's going on, pen? Oh, there we go. 6x plus 2y. Y is negative 3x plus 3 equals 1. Start by distributing. Negative 2 times negative 3 is negative 6x. 2 times positive 3 is positive 6. 6x minus 6 equals 1. I already see the pattern right there. 6 does not equal 1. 3 is no solution. Womp. I forgot to do the solution for the first one. 4, 2. Let's try number 4. See if I have enough room. I need to fix this equation, so I'm going to move the 3x to the other side. On the red one, I have negative 3x plus y equals negative 1. I'm going to add 3x to both sides to cancel that out to get the y by itself. So I have plus 3x over here, right? So 3x minus 1. It's going to be, so I'm going to rewrite that. 3x minus 1. Whoops. No, I'm not. Darn you. There we go. Y equals 3x minus 1 is going to be that new equation. So I'm going to substitute that, this y right here, in for here. So we're going to use the blue equation. We've got 2x minus y, which is minus 3x minus 1, equals negative 3. Now you notice this negative's on the outside. That means you have to apply it to both of them. You distribute it, so negative, this turns into 3x, and the negative, that turns into negative 3x, and then when I apply that to the negative 1, it turns into positive 1. So combine your like terms, 2x and negative 3x equal negative x, negative 1x plus 1 equal negative 3. Subtract 1 from both sides. That cancels. You're left with a negative 1x equals negative 4. That means positive x equals positive 4. So x equals 4. Let's plug that into the red equation now. So the red equation is y equals 3x minus 1. Not 3x, but 3 times 4, because x is 4, minus 1. That is 12 minus 1. That is 11. So y equals 11. Let's make sure that is true. Is it true for the blue equation? Does 2 times 4, that's 8. 8 minus 11. Does that equal negative 3? It does. All right, let's try number 5. Oh my goodness, we have a lot. So this one, we are going to substitute this y right here for this. So number 5, I'm going to use the red equation. 4x plus 2, and then in place of y, you're going to write negative 2x plus 5 equals 10. All right, let's do distribution. 2 times negative 2x is negative 4x. 2 times 5 is positive 10. Bring everything else down. Combine your like terms. That cancels. You end up with 10 equals 10, which is a true statement. Infinite solutions. Yay, let's try number 6. Oh, good. I can plug this in for that. So let's use the red equation. Do 6 over here if I can get away with it. Negative 2x, I don't know if I have enough room, plus 4y. Now y is going to be 1/2 x plus 4 equals 16. Barely enough room. Distribute. 4 times 1/2, positive 4 times y over 1/2 is 2x. Positive 4 times positive, I believe that is 4. That is going to be plus 16. That's going to bring down the 16 and bring down the negative 2x. That's a positive. So negative 2x, positive 2x, those cancel each other out. 16 equals 16. That is true. So this is also infinite solutions. Let's try number 7. Thank goodness, because I didn't have very much room. Number 7. Oh, good. I can replace this y right here with this y right there, which is that. So blue equation. Use that as my own main equation. We have 2x plus y, which is replacing y with negative 3 over 2x plus 1 equals 4. Let's distribute. Well, it's just distributing a positive, so everything stays the same. Minus 3 over 2x plus 1. Combine your like terms. I have 2x and minus 3 over 2. That's negative 1.5, basically. So I end up with 1/2 x plus 1 equals 4. Subtract 1 from both sides. I end up with 1/2 x equals 3. Multiply both sides by 2 in order to cancel that out, and you end up with x equals 6. All right, so x equals 6. Let's plug that back into the red equation, which is right over here. That is y equals negative 3 over 2x, x is 6, plus 1. That is 6, 12, 18. 18 divided by 2. That is going to be 9 plus 1. So y equals negative 9 plus 1. Y equals negative 8. Let's see if that's true. Let's make sure. So that's 6 and negative 8. So we just put it in the red equation. Let's go back in the blue equation. To 6 times 2, that's 12. 12 plus negative 8, so 12 minus 8. Does that equal 4? It does. Yay! 8, 9, 10, 11, 12. We got 5 more problems. And I'm almost out of room, so let's get to this. Let's try 8. Thankfully, this one's already in slope-intercept form. Replace this with this guy right here. So 8 is, let's do the blue equation as our main equation. Negative x plus 4, 1/4 x minus 7 equals 12. Distribute. 4 times 1/4 is x, 1x. 4 times negative 7, negative 28 equals 12. Negative x plus x. Combine those two like terms. You have negative 28 equals 12. That is no solution, or that symbol. Number 9. Gosh, I wish I can do something different. Let's move the x over. So if I were to do x plus y equals 5, subtract x from both sides, I end up with y equals negative x plus 5, which is going to be the equation I use instead. Y equals negative x plus 5. Cross that off. So now I know that this y can be replaced with this right here. So this is number 9. I'm going to do, base it on the blue equation. 3x minus y, which is negative x plus 5, equals negative 5. All right, apply that negative. 3x minus negative x is plus x, minus negative to the positive 5 is minus 5, equals negative 5. Combine your like terms. 3x and 1x is 4x, minus 5 equals negative 5. Add 5 to both sides. 4x equals 0. And x equals 0. Let's plug that into the red equation now. The red equation is y equals negative x plus 5. So let's do y equals, negative 0 is just 0 plus 5. So y is 5. So our answer would be 0 and 5. Let's see if that is true. 3 times 0 is 0. Minus 5 equals negative 5. Yep, that works. 10, 11, and 12. I am pretty much out of space, but let's go ahead and try to do what I can. Replace this y because this y is right there. Replace that y with this guy right here. So we're on number 10. We are doing 3x plus 4. Not y, but negative 3 over 4x plus 3. Equals 12. Distribute. 4 times negative 3 over 4 is negative 3x. And 4 times 3 is positive 12. Equals 12. 3x minus 3x. Combine those two like terms. 12 equals 12. That is infinite solutions. Thank goodness. Number 11. Y equals x minus 5, so we're going to replace that with this. Blue equation is the one I'm going to write. Number 11, I'm going to write it down here. Y equals, no, what am I thinking? Number 11 is 5x plus 2y. 2y gets replaced with x minus 5 equals negative 3. Let's distribute. 2 times x is 2x. Positive 2 times negative 5 is negative 10. Equals negative 3. 5x plus 2x. We know we're going to have a solution here. 5x and 2x is 7x. Minus 10 equals negative 3. Plus 10 to both sides. That gives us 7x equals 7. Divide by 7. X equals 1. All right, let's put it back in the red equation. This one right here. Y equals, instead of x, is 1 minus 5. Y equals negative 4. Let's see if that is true. 1, negative 4. Let's check that into the blue equation. 5 times 1 is 5, right? And 2 times negative 4 is negative 8. Does 5 minus 8 equal negative 3? It does, so that is correct. And let's do 12. Finally, number 12. Thank goodness. This is kind of easy. The y is already in there, so we're going to replace this y with negative 1/2 x. So, let's do 12 over there. Blue equation. 2x plus 4y equals 16. We are not writing y. We are writing whatever y is, which is negative 1/2 x. Equals 16. 4 times negative 1/2 is negative 2. Negative 2x equals 16. So 2x minus 2x, combine those like terms, that's nothing. So 0 equals 16. Is that true? No, it is no solution. That simple. Oh, that was a lot of questions. Go ahead and try some problems on your own. Good luck.